of them is going to be 2 days. So this will be a 2-day lesson, and then the next one will also be a 2-day lesson.
Well, I already know I can do really good on the first half.
That's good. Okay, so today we're graphing radicals. This means that I have given you an equation such as y equals the square root of x, and graph that. So there's something interesting about radicals that kind of prohibits us from plugging just any number into them. For example, what happens if I were to plug 3x there? Am I going to get a nice whole number answer?
No.
No. But what numbers could I plug in that would give me that nice pretty whole number answer?
4.
Perfect squares. So the ones that we like to plug in pretty much for every single example are 0 and 4 because they're really close to our axis, which makes sure that they're going to actually like fit on our graph. And they're also perfect squares. So we always plug in these 3 unless there's something else inside of the radical with. Yeah. So that is, remember when we start graphing these, Brandon. So let's go ahead and actually graph the function y equals the square root of x. On my xy table, I already know plugging in 0, 1, and 4. Let's also assume when we plug these in that we're only getting positive square root answers out of them. So what happens when I plug 0 in for x there?
0.
I get 0 because the square root of 0 is 0. We are all going to assume for these that it is only positive. What happens if I plug 1 in?
1.
1. Square root of 1 is, what about 4?
2.
2, because the square root of 4 is 2. Any questions about how I got 0, 1, and 2? So then I graph these like the coordinate pairs that they are. I only need 3 points on my coordinate plane in order to graph this function. So when I graph it, I start at 0, 0. My next point, 1, 1. And then my third point was 4, 2. An interesting characteristic about a radical function is that it doesn't go infinitely in both directions like a lot of graphs that we put down do. It starts at our first point and continues infinitely in whatever direction my points are going. So this is what the graph of a radical function should look like, just going infinitely in one direction. It is only going to be on one side. How do you feel about graphing this type of radical function? Good, bad, easy, seems incredibly difficult. What are we thinking? I think you mean if there was like a 5 in front of the x. Yes, then we would do whatever our number times that. But that changes it a little bit. And we'll look at something like that. But just this one, how did we feel about this? Easy, right? Not overly difficult. So let's try another one that's very similar. Before we actually graph this one and plug numbers in, I would like to point out that you need to be very specific about what's under your radical and what's not. So here, the x is under the radical, but the 3 is not. I see a lot of students, when they go and write this down, they will just extend that bar over the 3, and then it turns into a completely different problem. So if you need to, you can always put a vertical stop at the end of your radical so that you can always keep in mind where it's stopping and what it's including. That's just a little bar that comes down at the end. That is entirely your choice. It's up to you whether you use that or not. But just be very, very careful about where your radical stops and what it includes. So this one is the same concept. Do I have anything under the radical other than my x? No, which means the 3 numbers I can plug in are 0, 1, and 4. Just solving them out is going to include the extra step of adding the 3 to it. So I'm still plugging in 0, 1, and 4, and I'm still solving for whatever y is going to equal. 0 and for x.
0.
I get 0, and then I add 3 to it, and I get
3.
3. What happens when I plug 1 in for x? I get 1 and then add 3 to it, and it gives me 4. What happens when I plug 4 in for x? And we add 3 to it and we get?
5.
Look at that. We have 3 points and we're ready to graph. We started our first point, which was 0, 3. Remember, our x's go horizontal, our y's go vertical. We always do the x's first. I had no x, so I stay at 0, and I go up 3 to get my first point. My next one was 1, 4, so I go right 1, and I go up 4. And then my last one was 4, 5, so I go right 4, and I go up 5. And then I draw my graph. Again, it starts at whatever my first point was and continues infinitely in whichever way it's growing. Questions, concerns, or issues on that one? Yes.
How did you get 5?
I plugged 4 in here. I get the square root of 4 is what?
Oh, okay.
And then I added 3 to it. Yep. Any other questions? We're all good so far, right? No major concerns.
It's not hard yet.
Okay, so let's do another one.
Exactly.
What is different between this problem and the other problems that we have done?
The 2 is included.
I have another number grouped with my x under the square root sign, which changes the values that I can plug into it. We're still not just randomly getting x's that I can plug in. There's actually a way of finding them. When there's just an x, like to plug in 0, 1, and 4, correct? So what I do that's different is I take what's under the radical and I set that equal to the desired numbers 0, 1, and 4, and I solve. And then that's going to give me the x values that I would then plug into my radical. So on this one, I would add 2 across, and I get x equals 2. So that's one of the x's that I'm going to be plugging into this function to graph it. Same next one, I add 2 across, and I get x equals 3. So that's another one of the x's that I'll be plugging into this function. And then I do the same thing on the bottom, and I get x equals 6, which is the third x value that I'm then plugging in to the function. So instead of plugging in 0, 1, and 4 here, I'm plugging in 2, 3, and 6. We just took what was under the radical and set it equal to the 3 numbers that we like to use radical functions.
Turn into
So,
regular plus or subtract.
isn't this like same no matter how complicated it gets? Like if it's under the radical?
Yes, anything under the radical is set equal to 0 and 4 every single time. Yes.
No matter what we do, no matter what step you add,
Mhm.
it's those 2.
Always those 3 numbers for what's under the radical, yes. If it's outside of the radical, I don't care about it. I only care about changes inside of the radical.
Will there be squares in this?
Will there be squares?
Like square roots?
Well, we already technically have square root, but these ensure that we're gonna get a nice pretty whole number as our answer every single time. Other questions? Does that make sense? Do you see what I did here? So 0, 1, and 4, if you remember nothing else from this lesson, remember 1 and 4, because that will help you out more than anything else. So now what do I need to do with these new numbers 2, 3, and 6? I can't graph them without a y coordinate.
Oh, right.
Plug them in.
Plug them in, solve it out, and then graph the corresponding points. So what happens if I plug 2 in for x under my radical? I get 2 minus 2, which is 0, and what's the square root of 0?
0.
Perfect. What happens when I plug 3 in? I get 1, and the square root of 1 is 1. And then what happens when I plug 6 in?
You get 4.
I get 4, and the square root of 4 is 2. So now the points I'm plotting are 2, 0, 3, 1, and 6, 2. I plot the points. The first one is 2, 0. 2 is my x coordinate, so I go right 2. I'm not moving up or down at all, so that's where my point goes. My next one is 3, 1, so I move right 3 and up 1. And then my third one is 6, 2, so I move right 6 and up 2, and I draw my graph. How do we feel so far? Not bad? Not the worst thing I've ever had you do? Current questions, concerns, or issues so far? Okay, let's do another one. I'm actually going to give you guys this one to do on your own, and then we will come together and go for it. I will probably do 3 more today. It's the light cover and the air. Yeah. I'll get one of my other students to tighten it up. No, I'll get like, I don't know, Brock or somebody to do it. He's pretty tall. Okay, Kaylee, what am I gonna do first?
Write out thing. X minus 4.
What am I gonna do with that x minus 4?
Do equal to 0.
And equal to
1.
and what's the third one? What are the 3 magic numbers for radical equations? 0, 1, and 4. Good. So we set this equal to each of them, and we solve. And I get my 3 beautiful x's of 4, 5, and 8. Anybody else get 4, 5, and 8 for their x's? Okay. So then what do I do with those 4, 5, and 8? Plug them in and solve for their respective y's. I'm going to make an xy table just so I can keep track of it a lot easier. So when I plug in 4, what does my radical turn into? 0, and then we add 1 to it and we get 1. Awesome. So the y value for 4 is 1. What happens when I plug 5 into this? Radical is 1, and then I add 1 to it, and I get 2. And then I go ahead and plug 8 in. 8 minus 4 is 4. Square root of 4 is 2, and 2 plus 1 is 3. So yes, Camden was correct. So we get 4, 1, 5, 2, and 8, 3. Show of hands who else had these 3 points for their function. And then what's our last step, Ariana? Just to graph it. we go ahead and do that, I'm only drawing quadrant 1 because I know that's where it's going to exist, but you can draw the whole graph. So my first one is 4, 1. Then I had 5, 2. And then I had 3. And I draw my graph. Of course, yours could look different because I drew my y-axis very needed, but the concept is the same. Okay.
Will it be negative?
And where? As an answer.
Yeah, like, bottom left or bottom-
It could, yes, if we had a negative out in front, or if we were subtracting a really, really big number. It is possible, yes. Maybe we won't do it at all. You never know. If we did it, we do it tomorrow.
So in other words, we're doing it tomorrow? She's smiling, so
I think
yes.
you know me so well. Let's do another one.
It's gonna get harder tomorrow, there's no reason to be case.
Yeah, that's not true. She said one of them.
It's because we questioned it.
Nope, we're gonna talk about it in a second, but yeah. If you feel comfortable, you're more than welcome to move through this one and do it. As I'm looking at this, Grant, what do you think your first step is gonna be? Different question. Is there anything under the radical other than my x? No. So that means I'm using 3 numbers to graph this.
0, 1, and 4.
0, 1, and 4. Because there was no other change under that radical, I don't have to find new x's. I can just use the original 0, 1, and 4. That 2 out front just means that after I solve the radical, I multiply my answer by 2. So what happens when I plug 0 in for x here?
0.
I get 0, and 0 times 2 is still 0.
Yay.
What happens when I plug 1 in? We get 2. Square root of 1 is 1, times 2 is 2. What happens when I plug 4 in?
Oh,
I get 4 in general.
4.
Square root of 4 is 2. 2 times 2 is 4.
equal exchange.
I have 3 points. I can now graph it. We started at 0, 0. Then I was at 1, 2. And then at 4, 4. Questions, concerns, or issues so far? I know. But what fun would that be? Are we all okay so far? Yes. Y'all look bored. So very, very bored. We're going to do 2 more, and then that'll be it for today.
You should just print it out.
Yes, I did.
Is there room to?
I'll just do it like he.
I think there's-
Don't do any work, just write things.
I think there's room.
It's like,
That's the best way.
I would like you guys to work through this one on your own. So fix that one, I like the other one. We should have ended up with a graph that looks something like this. So I could use 0, 1, and 4 because there's nothing else under my radical except for the x. So when I plugged them in, whatever answer I got from the radical was multiplied by 2, and then I subtracted 5 from it. So when I plugged in 0, I got 0. 0 times 2 is 0, minus 5 is negative 5. When I plugged in 1, I got 1, which gave me 2, minus 5, which is negative 3. When I plugged in 4, I got 2. 2 times 2 is 4, minus 5 is negative 1. So we should have plotted the points 0, negative 5, 1, negative 3, and 4, negative 1. Show of hands, who had a graph that looked like that with these points. I don't see a lot of other hands up, which makes me very concerned. What issues did we run into? Did you have the points? Okay. How about you, honey?
Oh, I provided the -5.
Okay, so that is actually another mistake that I see happen a lot. Believe it or not. These two cannot be put together because this 2 is connected to the radical. So because these are connected, this cannot be combined with the 2 that's already there. I do see that happen a lot, so make sure you're very, very careful about what you can and cannot combine. If you're unsure, always take whatever number's out front and just move it so it's at the back, because then that usually fixes that issue. So don't, that's a really common issue, you're good. Do you understand though how we, okay. Any other questions, concerns, or issues? We're gonna do one more and then we're gonna call it a day. Sound good? Okay. This one's my favorite of today, just so you know. I like the word challenging, Pfeiffer. I think it sounds better.
Nope, can't do it. It's legal.
So why? So what, now I can use word hard and I can't use word soft. 2 new words I've learned this class.
But you can use aspirate and challenge it. I mean, give you alternatives.
And this is aspirate.
It
Sounds exhausting.
does. I
Not when you use it in certain terms. Sounds like you're trying to use verb, but then you still say
Wait, so.
I'm giving you guys a chance to try this one on your own. If we run into issues, I will start working through it in a bit and we can go over it. Yes, ma'am.
Okay, so this two is connected to it, right?
The 2 is connected, yes.
Oh, wait,
Wait.
Shouldn't it be?
yeah. One for you.
Hold on a second. Ebony has a question first. Are you stuck on the 7 one? Or which one?
Yeah, I'm just talking about like, how did you get 8?
16.
Okay, so I did 7. 7 minus 3 is 4, right? What's the square root of 4? 2 times 2 is plus 4. Okay.
So just essentially we have to do the times. Two on the outside. What happens if it's not like the other one has a -5, do every math set first and then do +4.
No, so if it was a -5 out front, you would still do the 2 times, and then you would just do -5. Or -5 plus 2 times.
So we would still be working with the first hypothetically still have +4, how would you then do the +4?
Yes.
So it doesn't matter.
Okay, so did everybody else, oops, get 3, 4, 4, 6, and 7, 8? Yes.
I thought you were asking if we got it.
Oh, no. You're good. And then what do I do next? I just graph it. First one I put down is 3, 4. Then I have 4, 6. And then I have 7, 8. So your graph should look something like that. Show of hands who had this come up as their answer. What issues do we have with this right now? Multiply in the wrong order, okay. It's not as, what?
Sometimes if you just did this, so we did something, it's like the parabola, is that what we do?
Yeah.
Alright, well, half the time the graph didn't fit on the graph, is that gonna be a problem?
That's the issue here because that's why we use the 0, 1, and the 4, so it's almost guaranteed to fit. Okay, no problem. Okay, Brenda Bailey to the office, or guidance office, I mean.
We've been everywhere today.
Again?
Yeah, they said it'll be quick.
Where?
Okay, before we finish,
Let's take a computer.
No, she just said you. She just said you. I would like a 1 to 5 from you guys. So 1, you have no idea what's happening. 5, you could show somebody else how to do it. How do you rate yourself?
I give myself a simple 3.
A simple 3. 3 is not bad. 4.5.
I do every time.
Okay, so that is it for, we'll go ahead and pass out your homework to you, and then you guys can get started on this, and then we'll finish it up tomorrow.
So Anthony, all your